Simplifying using Pythagorean identities. In the previous video, we were only using reciprocal and quotient identities to simplify. Now we're adding in these 9 Pythagorean identities that we talked about in the very first video from this section. So again, we're just being given as an expression, and all we're trying to do is simplify. Simplify using algebra. Simplify this to the least complex statement possible. Typically, it ends up being a singular trig function raised to a particular power, but whatever it is, as simple as possible. This is a little bit more complicated than what we were looking at before. And what my intuition says here is, hey, I see that there is a sine x in both of these terms, and I could pull out that sine x and have something that maybe possibly is Pythagorean identity related. So I pull it out. I have secant squared x minus tangent squared x left. I say, could that potentially be something interesting? Secant squared x minus tangent squared x? Well, indeed, it's 1 right up there. So that's it. It's you have sine x. That whole thing up there just is times 1 times 1, which is just sine x. Boom, not so bad. Whenever you can factor something out, try factoring it out. That's not always the right way to go, but sometimes it is. Oftentimes it is, I should say. All right, looking at this next one, cosine squared x minus sine squared x times cosine squared x. Again, same intuition I'm having here. I notice that there is a cosine squared x in both of these terms. I'm going to factor it out. So I have cosine squared x. When I pull it out from this first term, there's a 1 left over, and then a sine squared for the second term. Please note that what you're trying to do is maintain the trueness of the statement. So you should be able to go backwards. If I distributed the cosine squared to both of these terms, I would have cosine squared times 1, which is cosine squared, minus cosine squared times sine squared, which I have right over here. All right, so I have cosine squared x times 1 minus sine squared x. This to me looks like something that I could potentially see on my Pythagorean identities table, right? 1 minus sine squared. Oh, well, that is cosine squared. So we have cosine squared x that we pulled out. We have this 1 minus sine squared x, which is equal to cosine squared x. And if you have cosine squared x times cosine squared x, I posed this question to my class yesterday. There's 2 ways your brain is going to be thinking. Either your brain says, oh, well, that's 2 cosine squared x, or your brain says that it is cosine to the 4th x. And I want you to take a moment right now and think about which of these 2 it should be. Take a moment, think. Pause if needed. All right, that is the amount of time I'm giving you. So this first cosine squared x, really, that's just the same thing as cosine x times cosine x, right? The cosine squared. And the other cosine squared, same thing, right? It's just how many in a row I'm multiplying. But now I'm multiplying 4 of them in a row, which is the definition of cosine to the 4th x. So it is not this one, it is cosine to the 4th x. And that is the answer. That is as simplified as it can be. Very last one, 1 plus cotan squared x times sine squared x. Once again, I see this 1 plus cotan squared x. It makes me think, is there anything there? 1 plus cotan squared x is equal to cosecant squared x. Cosecant squared x, because cosecant squared x is equal to 1 plus cotan squared x. We saw that above. And then the sine squared is still there. Now, if you remember something I said in the previous video, when you multiply those soulmates together, they end up canceling each other out. I'm going to write it out explicitly here, but this is going to cancel. These are soulmates, and they're squared powers on both. It should cancel to 1. I'm going to change cosecant squared x into 1 over sine squared x, and now you can see it very obviously. Right? The sine squared, they both cancel. You're left with 1. And there it is. Some basic simplification. All right, so in our next video, we're going to start verifying the proofs of identities. And then in the following videos, we will be proving trigonometric identities. I will see you in that next video. Bye.